All right, so we have our extended proportion. The sine of angle A over side A equals the side of angle B over side B equals the sine of angle C over side C. Right? It's easy to see the visual comparison of what relates to each other. All right? So, in this scenario, can we use the law of cosines? Why would we do that?
Because it asks for sine.
But on your test, it does not dictate which one to use. So I'm asking you to visually understand which is better.
Because there's more than two angles.
I don't have two side lengths. So if I was going to use the law of cosines to solve for this, let's say I wanted to solve for b. The law of cosines would state b squared equals a squared plus c squared minus 2 times a times c cosine of 79. Now, who in their right mind would want to try and FOIL that out and factor that?
Me.
Nobody.
Obviously.
That's not good. So in this scenario, I would really like to use the law of sines to solve for a missing side length. How many angles do we have there? We have 3. But the third one's just not listed. But how many degrees are in a triangle?
180.
So if you do a little bit of math, 180 minus 79 and minus 63, it gives you the third angle. This angle is 38 degrees. So 38 and 12 match up to each other. 79 and B match up to each other, as well as 63 and A. So I have one proportion that's completely set up and ready to go. The sine of 38 over 12. That is one chunk of the law of sines. Now, you get to pick, do you want to solve for A or B? A. So we'll do the purple equation. The purple equation states the sine of 63 over A should be equal to the sine of 38 over 12. Those two match up to each other. Now, someone said that the parentheses help them organize their thoughts in the last class. So, remember, when you multiply trigonometric functions by side lengths, those two numbers don't talk to each other. So if I was going to do A times sine of 38, I would get A sine 38. Sine of 63 times 12 is 12 sine 63. Don't do any math yet. Keep simplifying. How do you get A by itself? Divide by sine of 38. This is the magic that needs to go into the machine. And you can type it in just like that. 12 sine 63 over sine 38. 12 sine 63 over sine 38. 17.3668. 17.3668 is A. Little a. There is one sneaky way to justify that answer right now. Does that answer make sense? Why?
Because it's bigger than.
It's bigger than
CA.
12, right? 38 is smaller than 63, so 12 should be smaller than 17, right? Or 63 is bigger than 38, so 17 should be bigger than 12. So I already have my blue equation set up. I know it's correct. So I can use this blue equation or this blue proportion to solve for the red one. The red equation looks like this. Sine of 79 over b is equal to sine of 38 over 12. Using that same blue equation but solving for a different proportion. So as you cross multiply, you get b sine 38 equals 12 sine 79. How do you get b by itself? Doing this for a reason. $19.1331. So the only thing that changed was the sine of the angle that I was talking about. So 12 sine 79 divided by sine 38 is 19.1331. Does that answer make sense? Yeah, it is the largest side opposite the largest angle. And you can go one layer deeper and say that 12 plus 17 is bigger than 19. So the triangle inequality theorem works. So the newest information today is this is the proportion, and then now it's how to work it out. So just a lot of different pieces to grab, a lot of different numbers. So one numerical mistake in your calculator could ruin you. All right, let's try another one. Give you a little bit of time to copy that one down, and we'll solve it together. What's the first thing you would do immediately? Find the missing angle. 75. So I would prefer to have a ratio that is completely filled out. And what is the only ratio that has all the parts to it?
B.
B. The sine of 80 over 12 is equal to, pick a letter, A or C. The sine of 75 over little a. So can you jump immediately to what we're going to solve, or do you need to do the cross multiply steps? Oops. Once you have that, divide both sides by sine of 80. So what is 12 sine 75 divided by sine 80? Tis confusion, or are you experiencing some sort of relief from this?
It's not confusing, but it just takes.
It takes a little bit of time. Takes a little bit of time. Alright. This is still an accurate representation of a formula we could use. So I could use this formula to solve for B or C, which would be the sine of 25 over little c, and cross multiply. What do you get for your last answer? 5.149. Then you check you kind of overlook your answers to see if they make sense. 25 is the smallest angle and 5 is the smallest side. 80 is the largest angle and 12 is the largest side. So everything kind of checks out. And then 5 plus 11 is 16, and 16 is bigger than 12. So the triangle does exist in geometry. Fun stuff, huh?
Yeah.
See or no?
Do we have to like round the decimals or?
I would really encourage you to use at least 4 decimal places. Because on your test, you have to do the law of sines to be able to do the law of cosines. Yeah? It's going to be great. Are you excited? On your test, you have to do the law of sines to determine the law of cosines.
So you want us to go to the process, please?
4 decimals. 10,000. 4 decimals. All right, and here's the hardest version. Why is it different? There is only one angle. Get the law of cosines. If you use the law of cosines here, it would be a disaster. The law of sines. So in this scenario, we have an angle here. And we have a side length here. Right? So I know that the sine of 51 over 36 is a correct proportion. Now, I know you want to solve for B, but B is missing an angle and B is missing a side length, so that will not work immediately. But you do have a 34 there. So the sine of C over 34 is also an accurate proportion. And student notices, now what are we solving for? C. And when you're solving for an angle, what kind of trigonometry should you be doing? Inverse trigonometry, right? We solve for an angle and use the inverse. So we still do the same thing. 36 sine C equals 34 sine 51. What do we divide by? 36. So the sine of C is equal to this monster. So I'll type that in. 34 sine 51. My calculator put 24. Which is confusing. 34 sine 51 divided by 36. 0.733971. So sine of C is equal to that number. How do I solve for C? Use the inverse. So the inverse sine of that answer is 47.2204 degrees, or 47.2204 degrees. And then I have two angles in a triangle. Can I find the third one? 180 minus 51 minus 47.2204. The other answer, the other angle is 81.7796. Now I can use that angle to solve for little b.
Can you go back to the part where you went from like 27.39 to 42?
I got sine of c equals that nasty decimal. When I'm solving for an angle, you pretty much divide by sine, or you do sine negative 1 of the decimal. So in the calculator, it kind of, I use like a super aggressive answer. And it gives you that 47.22 degrees. So now I have that b equals 81.7796. So I can use this equation, and I can solve for b, the sine of 81.7796 over little b, and I can cross multiply and solve for b. That's b sine 51 equals 36 sine 81.7796. Divide both sides by sine 51. Let's try it out. 36 sine 81.7796 divided by the sine of 51. 45.8474. We ever get a whole number? Maybe. How do you feel? Huh? So I tried this with 6th period just to try and make more sense. And this could be an absolute flop. Alright, let's say I gave you a triangle that looked like this. Starting over. That looks good. Look at this masterpiece. Brilliant, right? And the question wants to know, what's the area of the triangle?
Is the question like this going to be on our test?
This is just like what your test is.
That's so much work.
What? Shame on you. Yeah.
He told me. Wait, isn't that how 30, 60?
So I snuck it in there, right? So
Oh, that's it.
on your test, not so much. But look, we have an angle here and we have a missing side length here. Or for it is one huge triangle. So the only thing that you can justify right now is that this angle is 105 degrees. So by using the law of sines, you can say the sine of 30 over b equals the sine of 45 over 10. You could do that, right? And you could cross multiply and you get b equals 10 sine 30 over sine 45. Right? If you do all that math, you should get 5 square root of 2 right here. Yeah. You have to figure that out. Or so 10 sine 30 divided by sine 45. 10 sine 30, which is 5, divided by sine 45, which is the square root of 2. 7.07. That's the same thing as. Right? Tomorrow you'll learn that this is equal to 0.5 and this is equal to the square root of 2. So 0.5 times 5? What's 0.5 times 5?
2.5.
1/2 of 10 is 5.
Oh.
And the square root of 2 times b is b square root of 2. So to get rid of the square root of 2, then you multiply both sides by the square root of 2 and you get 5 square root of 2. Right? So 5 square root of 2 is the answer over here. And then you still don't have a height or a base, do you?
No.
So you could just do regular trig. The sine of 30 equals x over 10. And you should get 5 right here. You could use special right triangle tricks, or you could figure out how big this angle is. By doing inverse sine, you should get 60 and 45. And then you have all these other tricks. You can do 5 square roots of 3, 5 square roots of 2, and you can find all that math to get there. So I will give you the test question before you look at it so you can see the process. Both of the law of sine, law of cosine questions. I will give those to you. So we'll leave it there. All right, small change.